Assalamualaikum and good day everyone. This is a recorded lecture for chapter 8, Anova. Okay, so let's take a look at what we will learn in this chapter. So the objective of this chapter are to perform analysis of variance by hand, appropriately interpret results of analysis of variance test, and then we want to identify the appropriate hypothesis testing procedure based on type of outcome, variable, and number of samples. So what is the definition of ANOVA? ANOVA is basically analysis of variance. So it's a statistical method used to compare the means of 3 or more groups to determine if at least one group mean is significantly different from the others. Okay. So it's all about the hypothesis testing. So if you remember from previous week, we learned about hypothesis testing in chapter 6, but that one is only for one and two groups only. Okay, so here in this chapter, what happen if we have more than two groups? So we will use ANOVA. Okay, so you have more than two groups to compare. For example, you want to compare different treatments, regions, or time periods. Or you want to test if group different in means are statistically significant. So that is part of the ANOVA. So we want to test if the group difference in means are statistically significant or not. Okay, so these are the tail of F test. Okay, so last time we used Z and T distributions. So for ANOVA, so we will use the F statistics. So the rejection region is on the shaded regions here. So it's still the same, but we use the F statistic. Okay, so here is the rejection regions. So the rejection region is always right tail for ANOVA. Okay, of course, before this also we have both tail. Okay, right and left tail. Okay, but here in ANOVA only for one side. So what are the insight? So the insight for this chapter, for example, so we have the statistical outcome, which is whether we want to reject H naught or not. Okay, so here, example, under operation interpretation, for example, in this case is we want to see about the productivity, whether it's varied or not. Okay, so if let's say the outcome is reject H naught, so we can say that the productivity varied significantly by shift. So early shift B group outperform late shift C and D. So here later on we will see how this insight means. Okay. Here also I will explain later. So what are the steps involved in this ANOVA? So if you look here, this is like similar to hypothesis testing chapter. So we have 6 steps. First is the state hypothesis. 2 is the significant levels. Number 3 is the calculate test statistic. And then the 4th is state critical value. And then we compare the test statistic with the critical value. And then we make conclusions. So the hypothesis for ANOVA is this one only. So you just need to remember H naught is the equal of all the means, and then H1 is we want to say that at least two means are differ. Okay, so they are the same statement for all of the ANOVA problems. And then the significant level denote as alpha, and then you need to calculate the test statistic, which is you need all of this formula. So this is F test that you need to figure out, which is we given you the alpha, the DF1 and DF2. So this is like your critical value. Okay, so we need to calculate the test statistic first. So the test statistic is using this formula, alright? And then you need to know the MSB referred to the mean square for treatment between. Okay, and then MSW is the mean square for error within. So we have MSB and MSW to find the F. This F will be compared with the F, the critical value here. Okay, so you will have to find the MSB. This is denoted by the MSB, and then MSW. This is the equations. Okay, so here we have N. So because we have more than 2 groups, so N is the, later on we will see that. Okay, so this is example. First example, 5 treatments for fever blisters, including a placebo A, were randomly assigned to 25 patients. The data below show for each treatment the number of days from initial appearance of the blister until healing is complete. And then test the hypothesis at the 5% significant level that there is no difference between the 5 treatments with respect to mean time of healing. Okay, so remember the step before. So the first step is to state the hypothesis. So these are the data involved. So we have 5 treatments. So A, B, C, D, E is our 5 treatments. And then the value here is the data show the number of day, okay, from initial appearance. Okay, so these are the data recorded. So what you need to do? So first step is to state the hypothesis, which is we have how many we have 5 actually. We have 5, up to 5. Sorry, I think we have 5 here. Okay, we have up to 5 groups. So that is our first step. Second step is our alpha. The significant level is 0.05. Okay, so now we have to find the test statistic, which is our value of F. So the first thing is to calculate the MSB between mean for within. Okay, so you need to create this kind of table. Okay, since if you look into the formulation here, so we will have S. S refer to the standard deviations. SI, so we have up to 5 group. So we have up to 5 standard deviations. Groups 1 standard deviations, group 2 standard deviations, not standard deviation but variance. Group 3 variance, group 4 variance, up until group 5 variance. And the same goes to the means. Mean for each group. So we need to find the mean for group 1, group 2, group 3, up until group 5. And then we have N here. So N is referred to the number of data for each group. So if you look here, the data for each group, we have 5 data. Okay, means that for every group, N1 is 5, N2 is 5, up until N5 is 5. The total N is 25 data. Okay, so this is our big N. Alright. And then what else do we have in this formula? The XGM. Okay, so GM is the group mean for all of the group. Okay, so we need to find we know that mean is the summations of X divided by N. So since this is for all groups, so the summation of X is basically the summation of all of the data here, and then divide by the total number of data for all group. So this is 25. So 135 is the summation of all of this data. If you see in this table, I already assigned up to 5 row. First row, if for every group, we have every row, let's say A, Group A, we have data, 5 data. So summation of data, if you look here, where did I get 35? So 35 is coming from 5 plus 8 plus 7 plus 7 plus 8. So here summation is 35. Same goes to this 6, 10, 16, 19, 24. And then 6, 10, 14, 19, 23. And then here you get 11, 17, 23, 28. And then the summation for group E is 10, 50, 25. So that's how I get this number of summation of x on the on the third column. Okay, so this is the summation of data for each group, right? And then the summation of x all is 135. Divide by 25 to get the mean for the GM. Okay, and then grand mean, we call this as grand mean, the overall mean for all of data. Okay, so divide 135 by 25, you get 5.4. So that is for means for the grand means here. And then we need to calculate mean for each group. Okay, so we know that each group here basically with so mean for each group, so we have total mean for first group, for example group A, 35 divided by 5. So you get 35 divided by 5, this is equal to 7, and then you have 24 divided by 5, 4.8, 23 divided by 5, 4.6, 28 divided by 5 is 5.6, and then the last one, 25 divided by 5, you get 5. Okay, that is mean for each group. So let's say mean for group 1, which is our A, is 7. Then mean for group 2 is 4.8. So that's how we get this notations mean here. Mean I. Okay, mean for each group. Okay, then we need to calculate the variance since we have the S square. So S square refer to the variance. So the formula for variance is this one. Okay, so in exam they will not provide you with this formula, right? So what do we have in the formula here? We have the summations of every x value from the group, first group, for example. So this is represent as x1, x2, x3, x4, x5. So you need to square the value and then sum up all of the value here. And then you sum up the x first, which is 35. And then we divide by, we square, divide by n for the group 5. And then 5 minus 1 is 4. Okay, so if you look here, how do I get 251? Where did I get 251 here? Okay, so where did I get this one? 251. So it's not 35 square, but 251 is coming from which one? 251. So 251 is the square of this part. So let's say I add a square here, x square, xa square. So 5 square is 25 plus 64 plus 49 plus 49 plus 8 square is 64. So you total up this one, you will get what? So let's me calculate. 25 plus 64 plus 49 and then plus 49 plus 64. You get 251. Okay, so this is how you get the first notation here. Okay, for every group. So I represent group number A, B, C, D, and E. So second, so I show you another one. This is, let's say we square the x. 4 square is 16, 6 square is 36, 6 square is 36, 3 square is 9, 5 square is 25. And then you get the value here, which is 1, 2, 2. Okay, next same goes to C. So xc squared, 36, 16, 16, 5 square is 25, 4 square is 16. So here you get 109 summations. Okay, so this is summations. And then for x group D, square, we square 7 squares 49, 4 squares 16, 36, 36, 25. So the total up would be 162. And then the last one is 6 square. So let's say this is group the last group. 36, 25, 16, 6 is 36, 16. So the summation is 1, 2, 9. So I summarize this value. I put in this table so that we can see how to calculate variance later on. Okay, the formula for variance is here. Okay, so this is a long step, but if you practice, inshallah you can answer all of the questions. Okay, so we have already find the summations for x square. Okay, we got that here. Then we can substitute to find the s square lah. Oh, sorry. So here is for standard deviation. So we don't have the square root. For s square, so the s square, the variance is we don't have the square root. Then we square, divide by n, and then this is n minus 1. So that is how we get the value here. Okay, so let's calculate this first. Okay, so variance, for example, for group A, so we have summation of x square is 251. Substitute into the equations here, sorry. So 251 minus with summation of x 35, then we square the 35, divide by 5. Okay, divide by n, our n is 5, and then over the n minus 1. 5 minus 1 is 4. Okay, here. So you get this is 1.5, the variance. Same goes to the group 2. You need to find the variance. So summation of x square is 122 minus 24 square over 5. Divide by n minus 1, 4. So this is our answer. So you need to calculate this up until the end. Right? Okay, so dah calculate. We already done that part. So it just came here. Okay, we just calculate the input data that must be key in the MSB and MSW. Okay, we got the XGM. We got the mean for every group. We got the variance for every group. So let's find the between means square in between. So mean square in between. So this is summation for all of the group. So you need to calculate group for group by group. So here is for the group A, n is 5, mean is 7, minus with the mean of group grant 5.4. We square the value and then plus group B 5, 4.8 is the mean for group B, and then minus the grand mean, and then we square, and then up until group 5, n is 5, the mean is 5, minus with the what? The minus with the grand mean 5.4, then we square. So we need to sum up all of this, then we divide by 5 minus 1. Okay, forgot. So the K is the total group number. How many group number? K? 5. So K is the group number. Okay. So 5 minus 1. So we get 4. Sum up all of the value. Then we get mean square for in between is 4.7. Okay, done that part. So for the mean square within. So this is the formula. What do we need is the variance. Okay, and then the n. So we got the variance for every group. So the formula just now is the MSW is the summations of ni minus 1 si square over n minus k. N is for all data 25. K is the number of group, which is 5. Alright, so summation for every group. So we need to do group by group. So group 1, group A, n is 5, 5 minus 1, and then the variance is 1.5, plus group 2, n is 5 minus 1, and then variance for group 2 is 1.7, and then continue up until the group E, which is n is 5 minus 1, and then the variance is 1. Then you divide by n minus k. So these are the answer for mean square within. Okay, then we need to substitute the mean square within and between into F formula. So F formula is equal to what? The MSB over MSW. So 4.7 divided by 1.26, you get 3.73. Okay, done step 3. Step 4 is to state the critical value. So these are the things that you need, which is F alpha, and then we have the F1, degree of freedom 1, degree of freedom 2. So degree of freedom 1, this is the formula, K minus 1, group number minus 1, df2 is n minus k. So if you look here, actually the MSW below here is the df2. Okay, here is the df1. Okay, so df1, df2, degree of freedom 1 and 2. And then we know that our alpha is 5%. So there is 0.05. So from the F distribution table, find the find the degree of freedom 4. And then degree of freedom 2 is 20. So, okay. 0.05 is, this is the table of 0.05. So if you look into statistical book later on during the exam, there's a lot of F table. Okay, but you need to look into the F alpha with the alpha you want. There's some more table that have F alpha 0.5. So that is another table. So please take a look at the correct F table with the correct alpha. So here we use 0.05. So we need to look into the 0.05 F tables. Alright. So here the value just now is 2.87. Okay, so 2.87 is our critical value. Okay, 2.87 is our critical value. More than that, we reject hash not. Okay, so since our F from step 3 is 3.73, here, so it's lie in the rejection regions. So we need to conclude that the null hypothesis is rejected. So we can say that there is enough evidence that the mean has changed. Okay, you remember our H1? Our H1 is what? At least 2 means are different. So this one is support. Okay, our hypothesis one is support since the value of F is in the rejection regions. So we reject our H naught, which is this one is rejected lah. Okay, we reject this one. So we can say that there is enough evidence to support our H1. That mean has changed. Right. So it's a long process, long step, but please do exercises. Okay, please do exercises from tutorial. Okay, you have tutorial questions, so please do that. Okay, before the exam. Okay, so like I said, F table, you need to make sure you look for the table with the correct alpha, right? Okay, here, another example, example 2, we have 4 groups. So up to 4 groups. We have 4 groups here, and then we use alpha 0.01, and then determine whether there is a significant difference between the training method. Okay, so we have 4 training method. So we want to see whether there is any supported H1 is our at least 2 means are differ. And then H naught is, we have mean for group 1, group 2, group 3, and group 4. Okay, that is our first step. Step 2, the alpha. So our alpha is 0.01. And then step 3, calculate the test statistic. Okay, so here again, you need to sum up. So let's do it here lah, for you to see how I summarize into the another table. So you need to sum up all of the value here. So you will get this is 374. And then for the next part is 386. The third one is 265. And the last one is 282. And then remember, you need to calculate the square. So let's say I calculate it here. Since it's a very big number, but you still need to calculate. Okay, so this is 4, 4, 8, 9. 68 square is 4, 6, 2, 4. Then 61 square is 3, 7, 2, 1. 62 square is 3, 8, 4, 4. And then you have what? 60 square is 3,600. And then 56 square is 3,136. So you sum up this, you get the summation of x squared is 23434. 23434. And then it's continue lah, which is you need to sum up all of this. 59 square, 71 square, 60 square, 66 square. Sum up Same here, 46 square, 39 square, 38 square. No need to show in your final, just the last table I want to see lah. Okay, sum up this. And then the last part also sum up all of the square to get the answer for this column, right? So n is the number of data for every group. 1, 2, 3, 4, 5, 6. So 6 data, 6 data, 6 data, 6 data. The n big one is 24. So what is our k? The group number is 4. We have 4 group. Okay, so we have k, we have n. So again, you can find degree of freedom 1. Okay, and then degree of freedom 2. So degree of freedom 2 is n minus k. This is n minus 1. Right? Sorry. Not n minus 1. K minus 1. Sorry. So this is k minus 1. So k minus 1, 4 minus 1 is 3. And then this is n. 24 minus 3 is 21. Okay, so this is all of the information we need. And then we need to find the s square. So s square is the summations of x square minus summation of x mean square over n divided by n minus 1. Right? Look back into the formula. Oh, it's not, sorry, it's not means. It's x. Sorry. So here, x, summation of x. So, summation of x square is 2, 3, 4 minus with the summation of x. We square the value. We need to divide by n, which is 6. Divide by n minus 1, 5. You get this is S2. Okay, same until group 4. The square is this value minus with the x. Then we need to square the value, divide by n. N is 6. And then calculate the above nominator. Then divide by n minus 1. So these are the variance for each group. Right. And then again, I forgot, you need to calculate the mean for all, the grand mean. Okay, for all of this. So the summation of x is 1307 divided by the n is 24. So this is our grand mean, 54.45. Again, okay, so this will be given the formula in exam. So you no need to remember the MSB formula and so on. So this is summations of n. And then we have what? Means. Minus the grand mean. We square. And then this is k minus 1. Group. We have 4 group, right? And then MSW. So MSW is the summation of n minus 1 SI square over n minus k. Right? So these are the formula. So you just substitute all of the value you already calculated before. Mean for each group. So we have 4 groups. So we have 4 value you need to find out. Then divide by k minus 1. The group number minus 1. Substitute all of the value into the equation. And then this is our answer for MSB and MSW. Right? And then find the F. MSB divided by MSW. This is our answer. 30.14. After that, need to find the critical value using the F table. So since our alpha is 0.01, So our F is 0.01, degree of freedom 1, degree of freedom 2. So degree of freedom 1 is our K minus 1, so 3. And then degree of freedom 2 is N minus K, which is 24 minus 4 is 20. So this is from F table with alpha equal to 0.01. So you just need to find the value from the table using the degree of freedom 1 is what? 3 and 20. So our value here is 4.94. Is it? So there's a mistake here. Okay, there's a mistake here. So this is 4.94. 4.94, 4.94. So again, if you look into the shape bell curve here, this is our value 4.94. And then our statistic test is 30.14, which is inside the rejection regions. So means that we will reject H not reject. The null hypothesis is rejected. So means that we have enough evidence to support H1 that the mean has changed. Okay, you remember our H1 is at least 2 means are differ. Okay, so that is the step you need to find out. So if you look here, what are the insights of our answer just now? So we calculate the F statistic, which is 30.14. So if you look here, the 30.14 between group variance is it means that is 30 higher than within group variance. So if you look formula for our F here, okay, F 30, we get 30, right? So this is between and this is within. So dia adalah 30 times higher than within variance. Okay, so what should we do? So focus on optimizing the highest performing group. Okay, so which is the highest performing group here, if you look into the means, is the method B. Okay, so since this is the productivity. Okay, so if you look here, the highest productivity from the mean is the B, group B. Okay, group B. So that is what it's meant by the statistic value here. Okay, so kalau if you look group means here, the mean for B is 30, and then A is the next highest, and then C is the next part, 50% lower than B. So B is fastest. Okay, train all teams on method B, because we see that there's a lot of gap here. So what should we do? We need to train all team using the method B, and then we need to if you look here, A also less than B, right? And then D, we have D is basically berapa D? Sorry, that is the other, this is for the other problem solving. They only have 3, but if you look here, the highest mean is B, and then A, and then D, and then C. C is the lowest. So we can see that the method B is the fastest productivity. So follow B. Okay, train all team using method B, and then investigate why method C method C underperform lah. Why it have productivity the lowest. Okay, and then what about variance value? So variance value here, if you see, so that is from other example lah. But here, if you see into variance, So variance here is 28.4 up until 17.07. What does it mean? Okay, so there is a lot of inconsistency. The higher the variance, the higher the inconsistency. Okay, so we see here the highest value of variance is for method last D. Okay, method D. So what should we do? We need to standardize the work done lah, procedure, so that we can reduce the variability. Okay, so kalau you look into the data at first untuk group D, not here, the group D, so there is a variability in the productivity here. So what should they do? So they need to standardize the procedure so that the gap here is much less. Okay, so that's how we interpret the data and what is our next step. Alright, so that is the reason why we do ANOVA. Okay, we want to see whether for example, if we have a lot of method, so which method does they have the similar pattern, similar value? If they have similar value, so that means that the mean is equal. So means that all of maybe the methods are equivalent in the performance. Okay, so if they vary, F is very large, so we need to check between the group. Okay, between the group. So what should we do? Right. So that is the end of ANOVA chapter. So hopefully you can understand from the beginning up until the end. So in ANOVA, we have 6 steps to follow. First is to state the hypothesis. So this is the standard one, regardless of any questions. Okay, so if you remember in hypothesis section chapter 6, so H1 might be different, H0 also might be different. But in this case, ANOVA, so they are the same. Okay, and then we need to find the alpha. And then this is the formula to test using statistics. And then this is the critical value. And then you compare both value to see whether we need to reject or fail to reject the H0. Alright? Okay, so that's all. Hopefully you can perform well in your final. Okay, bye. Assalamualaikum.